Hello everyone, it's Benny, and today I have 3 announcements. Announcement 1. Some of you know I used to have an email address in my About page where you all could message me and talk about whatever. That is now up and running again, so if you want to talk to me outside of YouTube, you can do that. Announcement 2. A number of you have asked me about getting a Patreon page, so I went ahead and did that, and here's what I'm thinking. I'm thinking I can take the proceeds and I can invest them into new materials for the channel. Specifically, there's a whole bunch of books that I think they'd allow me to make much higher quality content, like real-time rendering, real-time collision detection, basically a whole bunch of books about the types of stuff I like to make videos on. They'd have good information, and I could take that into account and make better tutorials with it, I think. And also, there's on the more production end of things. Things would just make, well, creating videos a little bit easier. Like you might know, my microphone has a lot of, let's just say it's finicky and I have to do a lot of editing and working with it to get the sound that I do. So, a higher quality mic will definitely make making videos a whole lot easier for me. Plus, you get better sound quality, which is a nice little bonus. And there's a whole bunch of other things, but that's the general idea. I think that's a good plan. So that way, everyone ultimately wins in the end. That said, the Patreon page isn't really complete yet. I haven't done a whole bunch of fancy artwork for it yet. I haven't set up rewards, most notably. And the reason I haven't done that, I'm definitely interested in doing that. I think it's an awesome idea to set up rewards for people who want to do that. But I haven't been able to do that because I have a higher priority that I'm working on right now. And that is the subject of announcement 3. In my previous update, the one where I announced my grand return, I mentioned the possibility of perhaps doing a new game engine series. That idea has evolved a little bit. I was looking at my original game engine series and trying to figure out what exactly I wasn't happy with about it. And I realized that about 90% of the problems I had with it all came back to the same thing. You can't see why I'm designing the things in the way I'm doing, or why you'd want to do this, that, or the other, or how it's useful in any practical setting, all because, ultimately, I'm not making a game with it. I'm just essentially doing a laundry list of features. Here's what should be in a game engine. Here's how to implement it. That really is my biggest issue with that original series, and that's led me to my new idea. In a way, it's a bit like a hybrid series, because we're still going to end up with a new game engine, and that's still going to be 98% brand new content, never been seen before on any video in my channel. But the main focus of the series is not developing the engine, it's developing a 3D game. And yeah, that's the idea. The idea is we'll be making a 3D game, and we'll be adding on to the engine new features and new technology as the game needs it. So you can see both why this technology is necessary, why it's a good solution for an actual game, and as a bonus, you even get an actual game that uses it and you can play around with. I think it's just a really nice, elegant way to do things. But again, the main point of the series would be making an actual 3D game. And as such, I am tentatively dubbing this new idea the 3D Game Programming Tutorial Series. If it even ends up like that, who knows, maybe I'll come up with yet another evolution of the idea before we even get to that stage. But yeah, that's the idea, and I've been doing a lot of work just preparing the material to get that series off the ground. And I'd like to share with you what I've done so far. Now, I mentioned 90% of the reasons I was unhappy with my original 3D game engine series was because I didn't have an actual game with it. It didn't have context. The other 10% was boilerplate code, really. Just code that needed to be there, but didn't really teach you anything, didn't really add anything to the series other than it needed to be done. And I mean, that's okay if it's just a couple things, or maybe even just one video of, hey, boilerplate code in this video, but there are a couple sections where it ended up spanning multiple videos, and that, I'd rather have as much of the video content of the series focused on something actually useful and beneficial to everyone, rather than, hey, let's watch Benny write the boilerplate code that we need to do the actual interesting stuff. So, I've been trying to I've been trying to do as much of that code that needs to be there but doesn't really add anything to the series as I can ahead of time. And let me just say, so far, I think this looks like a pretty good call, because as you can see from clock, there's almost 9,000 lines of it so far, and I'm not even done writing it all yet. So I'm hoping this is going to end up saving me a lot of video time that would otherwise be spent writing, here, these are these getters we need to write. We need to make a wrapper class for this, and all that nonsense. Just get out of the way ahead of time, and the series can really focus on how do I make a 3D game, and how do I make a game engine that powers it. That said, I would like to share what I have in this background code so far, and what I'm planning to add before I start the series good and proper. And that's both, so hey, you know what I have, you know what I've been up to, but also, more importantly, so if you see something in there that's like, whoa, wait a minute, Benny. To me, that would make a whole lot more sense if you showed how to do that during the 3D game programming tutorial series, tentatively named. Well, if that's your reaction, then hey, let me know in the comments, and we can talk about it. I am definitely open to feedback on this. This is, in case it's not obvious so far, this is still me trying to figure out precisely what I want before I go all in it and make the series. And I'm still open to feedback. I'm still open to, hey, maybe this isn't the greatest idea so far. But yeah. So, I'll start with the biggest thing that I've done, and that is the 3D math library. Specifically, the 100% vectorized, fully simmed 3D math library. Yeah, here's the thing. In case you're not familiar, all modern CPUs, whether you're on desktop, laptop, mobile phones, anything, all of them have these special CPU instructions called SIMD instructions, stands for single instruction, multiple data, and they can do vector math in a single instruction. If you have your vector with 3 values and you want to add 2 vectors together, the CPU can do it in one instruction with those, well, SIMD instructions. Here's the catch. Modern compilers, by default, will not compile your code into SIMD instructions. There's various reasons for this, but they just won't. So if you want to take advantage of that for something where it makes sense, like, I don't know, vector math, then you're going to have to manually set up your code to use it. You're going to have to manually tell the compiler, hey, use these instructions to do the vector math. And it's a little bit of a pain. It's definitely an interesting exercise in compiler macros and platform detection. But, yeah, once you do it, it's a great way to do a 3D math library. Actually, I'd argue the code using the SIMD instructions is simpler and easier to write than without using the SIMD instructions. It's just a little bit of a different way of thinking about it, because, you know, it's interesting thinking, doing 4 elements of math at once. And yeah, I went ahead and wrote the whole math library with this. This includes the main, oh right, that includes file from somewhere else, but yeah, the main math. Though the main math isn't necessarily simmed for stuff like single float addition, because, well, why would you need that? But, you know. Point is, everything's simmed, from the matrix class to the vector class to the quaternions, the transform. I have a transform class. I also went ahead and implemented AABBs and spheres, and I actually tried to be pretty robust with this. There's AABBs, spheres, and planes, intersection routines between all of them. There's fancy algorithms to build really good bounding spheres and stuff. Ooh, yeah, I have intersect ray and line methods. I tried to be really thorough with this because I want this to be a pretty rock-solid 3D math library for any needs you want. Like the matrix class, if I go in here, you see these methods, you might recognize them from all the other series where I wrote a matrix class. These methods will create the standard matrices for you from some data, whether it's a scale matrix, a translation matrix, perspective matrix, etc. There's a whole bunch of matrix math operations. There's transposes, inverses, determinants. There's a function to extract the frustum planes. I believe I have a function to get the normal matrix here. Did I take that out? I'm like 90% sure I created a dedicated yeah, there it is, right there below me. 2 normal matrix. So yeah. Point is, I was pretty thorough with all this. I tried to have all the functionality I could reasonably anticipate us needing in the game engine. Of course, we can always add more to this later in the series if it turns out we need one very specific function in all these, but yeah, that's the general idea. And you could argue this is over the top. I mean, using SSE vectorization, or really any vectorization, it's not a trivial task. It's definitely an interesting problem. Writing vectorized math code for all this is definitely interesting. It's a whole different way of thinking about things. But the reason I decided this should probably not be in the 3D game series, as it is, really, it's because, as interesting as writing the basic 3D math routines is, to me at least, it's not really directly relevant to creating a 3D game or game engine. I'll definitely talk about what the math is and what it does, I just won't go through the in-depth, here's how to implement it yourself, that sort of thing. And if you're really interested in going really in-depth in 3D math, hey, let me know. Maybe I'll make a series on this is how 3D math for games works, or something like that. But yeah, that's definitely the biggest part of this project. It's been writing up this really nice 3D math class. Basically, my vision was like the direct 3D math library, except free, open source, and cross-platform. But yeah. The other big thing I did was I made a wrapper for the basic OpenGL functionality that you need to do just to get something 3D working to begin with. Basically, imagine the code from my Intro to Modern OpenGL tutorial, just wrapped behind a single class. That's basically what this is. And you could argue this is controversial. I mean, definitely creating OpenGL graphics is highly relevant to making a 3D game engine, but considering I already did that in the 3D game engine, I have a dedicated series on it in the Intro to Modern OpenGL tutorial, it didn't make sense to me to basically go through again on here's how to do basic OpenGL setup for making a 3D game again. So I went ahead and just created the basic stuff. As you can see, it's low-level stuff, like this is the function that creates a vertex array. This is a function that releases a vertex array. This is a function that creates the OpenGL concept of a 2D texture. This is a function that releases that. This is the function that issues a draw command for a vertex array. This is a function that clears the screen. So yeah, it's a wrapper for the low-level functionality. There's not really any high-level operations going on here. Just, again, basic wrapper for the stuff. I can even show you the code for this. As you can see, it's 700 lines of code, and well, the shader stuff gets a little bit in detail because shaders are just a detailed kind of thing like that. But, like I said, none of this should be alarming. It's not a whole rendering engine. We're gonna be writing the rendering engine as we need it. One thing I did do differently, though, is you might notice there's a few new concepts I didn't do exactly like I did in my Intro to Modern OpenGL tutorial. Like uniform buffers. Rather than operating on individual uniforms, this system operates on uniform buffers, which is same concept, just a little more efficient. It lets you update multiple uniforms at once. And, the sampler, rather than using the sampler directly attached to your 2D texture, hey, this is a function to directly create your own sampler. So you can use a nearest sampling or linear filtering or MIP maps or whatever you want, and you don't have to create a new texture every single time. So I've done a little bit of that, but yeah, it's not a rendering engine. We're still going to be creating that sort of stuff from scratch. This is just, it's a low-level backend. And one of the other reasons I did it a little bit, I organized it a little bit differently, is Vulkan compatibility. I'm definitely toying with the idea of maybe after the series is done, I can do a Vulkan tutorial, and wouldn't it be cool if I showed you a tutorial, hey, rather than here's yet another tutorial on how to set up and do basic Vulkan stuff, but rather, here's a tutorial on how you can write a Vulkan renderer for an actual 3D game that already exists. I think that would be a really cool idea. So, that's another thing I'm toying with. I think that's a cool idea. Spoiler alert, I definitely want to do a tutorial on Vulkan because Vulkan is the coolest thing to happen in 3D graphics in the last decade. Easily, no question. But anyways. Beyond that, it's mostly just various wrappers. Like, this is a wrapper for SDL window, because SDL windows are pretty straightforward to create, and if you really want to know how to do it, I already created a tutorial on it in the Intro to Modern OpenGL tutorial series. And I also did a wrapper for a few of the standard library things. There's a few reasons for that, most of which just go back to customizability. So like, this is my memory functions. As you can see, they're mostly like the C memory functions, but this allows us to customize it. So we can add, say, a memory 0 function, which is a very common operation, lets us set memory to 0. And not in the C standard library, but this way we have that along with every other memory operation we want, all in one common place, and we can easily extend this to add more or fewer methods if we really need to. And again, this way we don't have to think about, oh, where is this implemented? All the memory functions in the exact same place. And also allows us to extend existing functionality. Like, if you're using vectorized math, something that's important to think about is data alignment. So we have a malloc function that allows us to specify a specific data alignment, which could probably be very useful. So this will ensure that whatever pointer we allocate will be aligned at some certain boundary, which will make... that's important for simmed vectorization, that they have weird rules about loading and storing on aligned data boundaries. But yeah, so that's really the reason. To add new functionality, to customize existing functionality, and to have everything we could need in one common place to add to, remove from, or edit as we see fit. And it's not just memory, I also did that for math. I have a whole bunch of new math functions, actually. Like, I think I even have, like, a cubic interpolation function or something. Hang on. Yeah, I implemented Catmull-Rom interpolation because why not? Yeah, there's loads of specialized math functions that will be really useful for game development, but may not necessarily... Okay, they aren't in the standard library, and probably shouldn't be, because how many cases are you going to need Catmull-Rom interpolation outside of game development, or really other 3D applications? Yeah. So, I think actually it's just that and, the data structures. Like, that's really straightforward. I just defined stuff as std vector or std map, etc. Because I don't really plan to do too much different there, but that way, if for some reason we run into an issue with, hey, std vector does some really stupid memory management on this one platform and is causing memory fragmentation that's crashing our app. I've actually heard of stuff like that happening. This way, if we do for some reason run into that situation, hey, we aren't using std vector directly, we're using this array macro. So we can instead define this as some class that's like std vector but manages memory a little bit differently that doesn't cause all those issues, or something like that. That might be a little too paranoid, I don't know, but I've done it anyways because it's really easy to do. It's again, just a macro. And yeah, that's pretty much what I've done with all this. And yeah, that's pretty much what I have right now. Other than what I have, the only big thing I intend to add is a couple text processing utility functions, and support for loading at least JSON and maybe XML. We need some way to load text data in the engine, I think. I think that's going to be important. and probably not going to be the most exciting topic of all in a series that's supposed to be about making a game. And, I might come up with something else, but that's pretty much what I intend to do before this is feature complete for beginning the tutorial series. So yeah. I will probably be putting this up on GitHub sometime soon, maybe even by the time this video is up. I'll put the link in the description in that case. But yeah, this is open source things, even if I haven't officially released it. It's MIT licensed, as you can see right here. So you can pretty much do whatever you want with it. And, yeah, that's about all I have for this video. Thank you for joining me for this update. I hope you enjoyed, and I will see you in the next video. Take care.